Hey you guys, today we're going to talk about using logarithms to solve exponential equations. And this would be for the problems where you couldn't make the equation have like bases on both sides. So here's what you do. The first thing you do is you want to isolate the exponential expression, get it on a side by itself. The second thing you do is you're going to take the natural log on both sides of the equation. The third thing is you simplify using these properties, and this is the power rule. When you take the log of something being raised to a power, you can pull the power out front and multiply. Or you want to use the rule of natural log of e to the x equals x. Remember, natural log is just the log base e. So if you take the log base e of e to the x, that'll cancel and you're just left with x. And then the last thing you'll do is just solve for the variable. So let's get started. All right, so for the first few that we do, we're just going to express our solution in terms of natural log. So we're not going to put it in the calculator. We're going to leave the answer with the natural log in there. So let's look at number one. So the first thing I want to do, or step one, is isolate the exponential expression. That's already been done. Step two is I'm going to take the natural log of both sides. So I do the natural log of 9 to the 7x is equal to the natural log of 4.9. All right, and now I'm going to move this exponent out front and multiply. So I have 7x times the natural log of 9 is equal to the natural log of 4.9. To undo this multiplication, I'm going to divide. Now this is being multiplied with x and the 7's being multiplied by x. So I'm going to divide by all that at one time. So 7 natural log of 9. Do it on the other side. All right, so the natural log of 9 will cancel, the 7's will cancel. And we get x is equal to the natural log of 4.9 divided by 7 times the natural log of 9. And I'm going to leave it just like that. All right, let's look at the second one. We have 3 to the x plus 8 equals 7. The exponential expression's isolated, so I'm going to take the natural log of both sides. So we have the natural log of 3 to the x plus 8 is equal to the natural log of 7. I'm going to use that power rule and bring that out front. So we have x plus 8 times the natural log of 3 is equal to the natural log of 7. Rather than distributing the natural log of 3, I'm just going to go ahead and divide both sides by the natural log of 3. All right, and now we have x plus 8 is equal to the natural log of 7 divided by the natural log of 3. And to get rid of a plus 8, we are just going to subtract and do it to the other side. So we get x is equal to the natural log of 7 divided by the natural log of 3 minus 8. All right, let's do a couple more like this. All right, for the third one, we have e to the 5x equals 3, so we're going to use that other property. The exponential expression is already isolated, so I'm going to take the natural log of both sides. So we have the natural log of e to the 5x is equal to the natural log of 3. And then remember, the natural log with this e is going to cancel, so you just get 5x equals the natural log of 3. To undo multiplication, we divide. So x is equal to the natural log of 3 divided by 5, and we're done. Those are easy. We like those. All right, let's look at number 4. Same thing. I'm going to take the natural log of both sides. E to the x plus 8 is equal to the natural log of 6. All right, this is just going to cancel out because natural log is log base e. So we are left with x plus 8 equals the natural log of 6. How do we get rid of a plus 8? Well, we subtract. And we get x equals the natural log of 6 minus 8. And now I want to do a couple where we put it in the calculator and approximate our answer. So let's do two like that. So for these, the directions will say something like solve and use a calculator to approximate the solution, and I'm going to go to the hundredths place. So let's look at number 5. All right, I'm going to take the natural log of both sides, and I want to note, in theory, we could take the log of both sides, but I'm just going to stick with what we got. So the natural log of 10 to the x is equal to the natural log of 4.95. All right, I'm going to use my property and pull that x out front. So we have x times the natural log of 10 equals the natural log of 4.95. I wait to the very last step to use the calculator, so I'm going to go ahead and divide by the natural log of 10 on both sides. So we get x is equal to the natural log of 4.95 divided by the natural log of 10. And now I'm going to get out my calculator and put that in. Can you see? So natural log of 4.95, close your parenthesis, divided by the natural log of 10. All right, so we get that that is approximately 0.6. Now it's 9/4, so the 9 will look at the 4 and stay the same. All right, let's do one more like that. We have 4 to the x equals 15. The exponential expression is isolated, so I'm going to take the natural log of both sides. So the natural log of 4 to the x is equal to the natural log of 15. I'm going to put that x out front using my power rule. So x times the natural log of 4 is equal to the natural log of 15. This is being multiplied, so I'm going to divide both sides by the natural log of 4. All right, and we get x is approximately, I'm going to put that in the calculator. Clear that out. Whoops. So we got the natural log of 15 divided by the natural log of 4. And we get 1.9. The 5 is going to look at the 3 and stay the same. So my answer will be approximately 1.95. All right, that's it for today.